Zoom right now. Okay, so I know with stoichiometry, I've been doing a lot of general chemistry too for students. Now, what I'm going to also do here, I'm going to let me screen share. But if you all want to follow me on my YouTube channel, is Learn Chemistry with Professor TK the Chemist. Okay, Learn Chemistry with Professor TK the Chemist. So I'm going to actually share my screen so that you guys can actually see what we're going to get into today also. Okay, let me make sure. Okay, so give me 1 second. Okay, I want to make sure it's on YouTube too. So, okay, yeah, there it is right there. I want to make sure it's on YouTube too. Okay. So we're on YouTube now. So those of you all that want to follow along with me, by all means do. So we're going to go ahead and get into our content today. I know there's a lot that we have to cover, and I want to make sure that you guys get what you need. Okay. And so hold on, give me one more chance, one more time to make sure everything's where it needs to be, because there's a lot of feedback. Okay. All right. Okay, guys. So I'm ready to go ahead. You're stuck on the mold questions on your homework, Giselle. Okay, so we can go ahead and actually get into that as well. So when it comes to molds, one of the things that I have to kind of pinpoint with you guys is that it deals with, of course, moles, molar mass calculations. Okay, so when you talk about moles and all of that stuff, it's not just the thing that you find on your face or on parts of your body. Moles deals with the periodic table and having to find the weight for that compound or element. So for instance, if I say convert, let's say 4.7 grams of, we're going to keep it basic for right now so you guys can see this, okay? Okay, so what I'm going to do, let me see, let me put a different compound here. What if I said convert 4.7 grams of neon to a mole? Here's what you got to do, okay? You have to take and find the molar mass of neon, okay? So you need to find the molar mass of neon, which if we look at our periodic table, make sure you guys got that as well. Yes, the molar mass of neon. So when I pull up my periodic table, all right, I have the mass of 20.18, as you guys can see right here, 20.18. That is the molar mass, okay? So when you get the molar mass of neon, which is 20.18, that's going to give you the molecular weight. Now, what I want to also point out, yes, you do need that table. Yes, yes, yes. What I also want to pull out is that whenever you are looking at your conversions, let me kind of give you all some background information because this is actually going to help you for stoichiometry as well. Okay. Stoichiometry is something that you need when it comes to balancing equations, and you're having to put all that together. So you will need that also, even with this particular process. So when it comes to balancing, to doing molar mass calculations and moles, what you need to know is that when you look at molar mass, if I told you that the molar mass for neon was 20.18 grams over 1 mole, that's the conversion. I can also flip that and say 1 mole of that is equal to 20.18 grams, okay? So depending on how you use it, you would have to use one or the other. It's no different than if I told you to convert, let's say 4 quarters to $1 or $1 to 4/4. It depends on how you're going to use your calculation, okay? So I can either use the top or the bottom. So I can say, in this particular case, 4.7 grams of neon, convert that to a mole. I would have to start off with 4.7 grams of neon times. Now, again, you always want to make sure, yes, Talon, you said 2 sig figs. That is correct. If I give you the starting number and 2 significant digits, but my molecular weight is in 4 significant digits, you still go with the least amount. So yes, you're absolutely correct about that. Absolutely. Now remember, we're trying to get to a mole, so 1 mole of neon is on the very top. And again, 1 mole of neon is equivalent to its weight. So what I'm going to do now is, like someone just posted in the chat, you're going to divide those two numbers. So whenever you're going from a gram to a mole, you will divide, okay? You will divide by the molar mass. That's something that you want to keep in mind. And as I always say, you want to do what? Keep these conversions or these formulas on your note cards. Always have your note cards available. And so you're going to cancel out your grams because you don't need those units anymore, but you do need what's left over, which are your moles. Okay? So when we plug this into our calculator, I'm going to say 4.7 divided by 20.18. And this gives me 0.233. But remember, we only need 2 of those significant digits. So my final answer will be 0.23 moles of neon. Okay, Giselle. Okay. So they were asking how many moles of aluminum. Yes. Okay. So what I can do for that, that would be one in which we'll get to that part, okay, with stoichiometry. Yes, we'll get to that one. Now, let me say this. If you were given, let's say a compound, and you had to do the same thing over here, okay? If you're given a compound, how would you solve this problem? Well, it's the same way, okay? You would do this the same way. So let me show you this as an example, okay? Suppose I gave you 42.3 grams of H2O. And I say convert that to a mole, okay? Mole, and again, the mole of the unit for mole is MOL. And yes, Brian, this is considered dimensional analysis. Yes, that is correct. Yes. Compounds have molar mass as well, Giselle. That is correct. So for instance, if I am looking at the molar mass of water, first thing you got to do, again, in order to convert the grams, okay, to a mole, you have to do what? Find the molar mass, okay? So when you're going from a gram to a mole, you know you're going to divide by the molar mass of H2O. Now, again, if you forgot how to find the molar mass, let me help you out on that. So to find the molar mass of H2O, all you have to do is separate everything out. You've got 2 hydrogens and you have 1 oxygen. And yes, you're going to multiply by their weights. And the weight on the periodic table for hydrogen is 1.08, and the weight for oxygen is 16.00. And so you get right here 2.016 for hydrogen. And then for oxygen, 16.00. Of course, you're going to add those two together, and you end up with 18.02, because you always multiply and round off to the least amount of significant digits, okay? Okay, yes, Diane, you want to see the first one? Yes, let me go back up here for you. Matter of fact, let me scoot it up a little bit right here. Okay. There's a lot going on with this one. Let me hold on for 1 second, Diane. Let me this one. Okay, there we go, because it was scooching up a little bit. There we go. Okay, so here we are. So with the first one, the 4.7 grams of neon to a mole, you had to convert that to a mole by dividing by the molar mass of neon. The molar mass is the weight, okay, on the periodic table. Okay, great, great, great. Okay, now let's take a look at this next one. We've got 42.3 grams of water that you're converting to a mole. The first thing you need to do is to divide by the molar mass of water. Now, if your teachers don't give you the molar mass, you've got to find it. So to find the molar mass of water, what you have to do is separate them out. I've got 2 hydrogens times its weight on the periodic table. I've got 1 oxygen times its molecular weight on the periodic table, which is 16.00. So we multiply the 2 times the 1.008 and the 1 times the 16.00, and we get 18.02. Now, again, how do we get that? Because when you do your calculations, okay, you round off to when you're adding, you go at the least amount after the decimal, so that 18.016 becomes 18.02. Okay. Yes, extra ortas or ortis. Yes, I am going to do stoichiometry. This is actually the precursor to stoichiometry. Because if you don't do this, you won't get the stoichiometry. But yes, I am going to go over the stoichiometry after this part. Yep, I sure am. So right here, you've got your molar mass of water. So now all you got to do is take that number, the 42.3 grams of water times. Now remember, because we're saying times, we're just setting it up where we're canceling out our like terms. So again, on the bottom, we're going to put the 18.02 grams of water, because again, that's the molar mass. And on the very top, we're going to put 1 mole, okay, of water. And now, again, like we said before, we're going to get rid of our like units, our like terms, cancel those out. Okay, I got you. I got you. Okay, Selena, very good. So if you guys need any help, please make sure that you all follow me. And also don't forget to book a session with me if you need some help that I can't, like if I'm not able to answer your questions here on the live for the free 99, by all means, book you a tutoring session and it will be well worth it. Okay, very good, guys, very good. So you've got 42.3 divided by 18.02. Okay, so you've got 2.347, all those numbers, but you only need 3 of them. So 2.347 becomes 2.35 moles of water. Ellen, I've done wavelength. I have some videos on my channel on wavelength. Yes, you can actually go to my YouTube channel to get the wavelength calculation problems. Okay, so now, and I'm live now on YouTube. For those of you guys that want to join me over there, you can. I just can't see the comments. So if you are putting any comments down, I apologize because I can't see them with with my computer, because I'll get a lot of feedback. Yes, I'll be going over sig figs. Yes, yes. I repeat sig figs throughout our conversation. Every time I'm doing these calculations, I'm always remind you of the significant digits, always. Whenever you're multiplying and dividing your numbers with significant digits, you always go with the least amount of those numbers. So right here, I've got 3 sig figs and 42.3, but I've got 4 sig figs and 18.02. So when I divide those two numbers, I'm going to make sure that I get the least of those digits, and that's why I rounded off to just 3. Okay, so Diane, you said you're having a hard time with the labeling to be able to cancel them out at the end. You get lost. Okay, okay, well, let's keep going. Let's keep going. So maybe you'll find a problem that kind of hits you with that. Okay, so let's do another problem. But this time, suppose I have a problem where you're now having to convert a mole to a gram, okay? So if you're having to convert moles to grams, you're going to multiply by the molar mass. Okay, so if you are converting a mole to a gram, you're going to have to multiply by the molar mass. Okay, so moles and molar mass. Molar mass is the weight. So if I say how many pounds you weigh, okay, we'll say, all right, I weigh 200 pounds. But if I ask you how much does water weigh, you would have to separate each element out like we did up here to get the weight, individual weights for the individual elements, but then you got to combine all those numbers together to get the final weight here. So if I say molar mass, we're talking about the weight. How much does that compound or that element weighs? And you have to use that number when it comes to providing the molar mass calculation for different elements, but you also need it, of course, for solving for your moles and grams and stoichiometry-based problems. I hope that answered your question. So now when we get to the moles and you're going to convert that to a gram, what you're going to have to do, like I said before, is to multiply by the molar mass. So for instance, if I told you that you have 2.35, like we just did before, let's say a moles of aluminum, and I want you to convert that to a gram. Well, first thing you need to do, step one, of course, like we've said before, find the molar mass of aluminum. So we're going to use our periodic table to find that, okay? All right. Starching, yes. Just like I don't use P-Chem either, physical chemistry. Yeah, certain things in chemistry you don't need or I don't want to say you don't need, you don't utilize. When I look at my periodic table for aluminum, hey, Dr. Fudge, how are you? When I look at my periodic table for aluminum, you see the weight here is 26.98. I know it's a little blurry. Let me back it back. 26.98, okay? That is the weight for aluminum, 26.98. So because I know that that's the weight, 26.98 grams per mole, you remember how I told you earlier, you'll either put 26.98 grams of aluminum per 1 mole of aluminum. You can write it like this, or you can say 1 mole of aluminum over 26.98 grams of aluminum. It depends on how you actually are trying to solve your problem. Well, in the first example that we gave, when we were converting a gram to a mole, we had to put the moles on the top. We had to use this format right here. But now, since we're converting a mole to a gram, we're going to actually use this format right here. So the unit you're trying to get to, that's the one you want to put on the very top, okay? So if I go back to my problem, I have 2.35 moles of aluminum. So let me write that here, 2.35 moles of aluminum times. So on the very top, I'm going to put that 26.98 grams of aluminum. And on the very bottom, 1 mole of aluminum. And you just like you said, Jazeel, you're going to do what? Cancel them bad boys out. So moles goes away, but not the number that's associated with it. Yes, raised for 8U. I know I'm messing it up. Yes, I'm glad you found me as well. Yes, yes, yes. So now remember, all you got to do is multiply these two numbers, 2.35 times 26.98. And that is correct, Jazeel, 3 significant digits. So 2.35 times 26.98. So although you get this number here, 63.403, you know that your final answer has to be only 3 of those digits. So 63.4 grams of aluminum, okay? That is your final answer. Now, again, yep. So I'm actually, it's called a Wacom pad. I've had this for almost 10 years or so right here. It's called a Wacom. They may be called something different now, but it's like you plug this up into your you as a USB port, and then it comes with this little pen device right here. And I think at the time I paid like $70 or $80 for it. Ori and I love chemistry more. I know, right, hot dog? I can't even use my finger to even move around on the screen like that. Yes, I gotta make sure. Well, sometimes whenever I'm writing out, the pad is like this. So when I'm writing out, you see what I'm doing, right? I'm writing, scratching this up, but you see how much I've made on the screen in doing that. So let me erase that scribble scrab for the demo purpose. So, okay. All right. Let's see here. Once you get it in, you'll figure it out. You will figure it out. Yep. Hey, Steve. Hey, Bree. All right. Now, the next thing, we just dealt with an element here where we dealt with aluminum. But again, suppose I told you guys that you had a compound, okay? Let's say that the compound was for aluminum oxide, okay? So again, let me give you a made up number here again. Let's say that we were dealing with um, 80.44 moles of aluminum oxide. Now, let me also say this too. Okay, oh, hello, not for Z3D. Yes, I will still be on YouTube, and I'm glad you asked that question. I'm so glad you asked that question because if they do that, you guys need to come follow me on my YouTube channel. Learn Chemistry with Professor TK the Chemist. And I'm live over there right now. So if anything should happen to this platform, you guys make sure you follow me over there. Learn Chemistry with Professor TK the Chemist. Yes, thank you so much for asking that question. Yeah, and that's real. Congress want to fight about that, but y'all don't get me on my political soapbox. Woo! Yes. We got bigger issues to talk about, right? But they want to debate that. And I get it. I know part of the reason why, but social media is social media. You're welcome, Giselle. You're welcome. So if your teachers if they told you aluminum oxide like this, and you did not know how to write the formula, you'd be in a world of trouble. So your teachers are going to assume that you know how to write the formula. So just real quick, as a quick recap on writing the formula out, I know that the charge for aluminum is 2. I'm sorry, originally was 3. The charge for oxygen was originally 2. So they do a swap. So you get Al2, of course, O3. Okay, O3. So that's your formula. I know, right, Giselle? For real. Yes. But y'all know it's bigger than what they say. You know. Mm-hmm. You know. So if we're converting 80.44 moles of aluminum oxide to grams of aluminum oxide, you all know what we need to do, right? We've got to calculate the molar mass of aluminum oxide. So first thing we're going to do is separate each of those elements out individually. You've got 2 aluminums times, and for the sake of argument, well, no. I was going to round it off to 27, but we'll keep the numbers as is, okay? I'm not going to get y'all off with that. And then oxygen is 3 times 16.00. So now we're going to do 2 times 26.98, and we get 53.96. And then we're going to add that to the 48 for the weight for for oxygen. We had 3 of those times 16, that gave us 48. So you add these two together, and let me scroll my screen up so y'all can see it. And you get 101.96 grams per mole. Okay, that's your molar mass. So now that you've got that part, you're going to take the 80.44 moles of aluminum oxide. And remember, because we're trying to get to a gram, like we've said before, you have to multiply by the molar mass. And I'm abbreviating MM for space purposes. MM is molar mass. Okay, so you're going to put the weight, that 101.96 grams of aluminum oxide on the top, and on the very bottom, 1 mole. Okay, so that those units can cancel out. So 1 mole of aluminum oxide is on the very bottom, and you all know what to do. Cross out those like terms, okay? So we're going to take that 101.96 and multiply times 80.44. Now, you do get this ginormous number, if that's even a word. We get 8,201.66. So I know, let me write all that out, 8,201.66. Remember, we only need 4 of those numbers because of our significant digits rule. So our answer would actually become what? If you only need 4 of those significant numbers, what will your final answer become out of this? Because that's not the answer you would record. And your chemistry teacher is going to make sure that you write down the correct answer. If you need 4 significant digits or 4 significant figures. That is correct, Giselle. Excellent answer and excellent job. 8202 grams of aluminum oxide. Okay. So I know sometimes the answer will be in scientific notation. How does that work? Okay, so here's the thing. If the answer is given to you like this, 8,202, that typically doesn't warrant a scientific notation. But if you had to put the answer in scientific notation, let me show you what you would do for that. Okay. So if you have 8,202, and I said put the answer in scientific notation, you're going to move your decimal 1, 2, 3 places to the left between the first 2 significant digits, and you get 8.202 times 10 to the third power. And the reason why it's 3 is because you moved it 3 places to the left. Had I moved my decimal to the right, the exponent would have been negative. Okay? It would have been negative. Now, I know some of you guys have asked me about a stoichiometry problem. Okay? And what do you mean, can you drink that, Giselle? You're welcome, Aubrey. You're welcome. Okay, so I know that several of you guys have asked me about stoichiometry. Is the person still on that wanted to do a stoichiometry problem? And if you are, just give me a thumbs up if you're still on. And Diane, are you still on? Because I know you had asked a question also about moles, and you had specific concerns about how to convert. Yes, Giselle, what was your problem also? You talking about stoichiometry, Giselle? Okay, Diana, so do you want me to do a problem with mole conversions? Aubrey, what type of conversions? So for instance, like in my book, y'all know if y'all could see my library, I have so many chemistry books. So when you think about teachers who say you can't take your test home because um, they don't make enough tests, that's because some teachers are lazy. When I say they're lazy, do you see how many problems I have in here? I can literally flip these problems and give you different numbers for the same problem. Like teachers that don't want you all to take the test home because they're afraid that you're going to let the other students know what the test questions were. They should be able to make multiple test questions. I've been teaching for over 25 years, so I have a slew of problems. Okay, so but I digress. Well, I mean, this book is over 15 years old, and this is a book that I got from like ancillary materials that we get as teachers. So, and I'm working on a book myself because I know so many students have asked me questions like that before. Okay, Giselle, let me go ahead and take your question, and Diana as well. Okay, so I'm going to screenshot this. Let me see if I can, let me see. I'm learning how to pin comments. Let me see. In this comment. Okay, so how many moles of aluminum are made if 1.34 moles of aluminum iodide react with 3. Okay, let me write the question that you had down. Okay. And Diana, yeah. So okay, all right. So here's what I'm gonna do. I'm gonna do Diana's question first because that's gonna be a quick question, and then I'll come back to your question, Giselle. Yes, I'm gonna do Diana's question first. Okay, so Diana, she said, how many water molecules are there in 10 grams in a 10-gram sample? So you've got 10.0 grams of water that you have to convert to a molecule. Okay, of water. So here's the deal. When you are going from a gram to a molecule, okay, that's the same as going to an atom. Those two are the same thing. So you got to use Avogadro's number, okay? So here's the thing though. You're going to go from a gram to a mole, and then the mole to that molecule. So this is a two-step problem, okay? So with this first step right here, you would need to find the molar mass, okay? So let me highlight this so you'll know. So to go from a gram to a mole, you need to find the molar mass of water, okay? And I'm going to put over here for this part right here, you're going to use Avogadro's number, 6.022 times 10 to the 23rd, okay? So those are two things that you need to know in order to do this problem, okay? So right here, I'm going to go very slow so you can see that. Earlier, we found the molar mass for water, which was 18.02 grams per mole, okay? So we already found that, so we don't have to go through that step. So what you're going to do, you're going to say 10.0 grams of water times. Now, on the very top, I'm going to put 1 mole of water. And on the very bottom, 18.02 grams of water. Now, remember, whatever you start with, you want to put that on the bottom. That's how you know, Diana, which one is which. The number you start with, you want to put on the bottom so they can cancel out, okay? The number you start with, you want to put on the bottom in terms of the molar mass so they can cancel out. Now, you're left with moles, but you're not done because you got to convert that to a molecule, okay? Remember, on the bottom, I'm going to put 1 mole of water is equal to Avogadro's number. And I'm going to put molecules. That's going to be a little sloppy right there, the way I wrote that. But that's molecules. I know it's kind of sloppy. That's molecules that's squeezed in over there. So to make this make sense, as we say, make it make sense, what we're going to do is multiply 10.0 times 6.022 times 10 to the 23rd, and then divide that by 18.02, okay? So that you all can see this, okay, in real time. We're going to do this together. So you've got 10.0 grams times 6.022 times 10 to the 23rd, and then divide that by 18.02. And we get 3.34 times 10 to the 23rd. Okay, 3.34 times 10 to the 23rd. That's molecules of H2O. So again, let me scroll this up so you can see that. Okay. Did that make sense, Diana? Did that make sense? And again, you can go back and look at this on my YouTube channel because I'm actually live now. Okay, excellent. I'm live right now on YouTube. So in case you need to go back and look at this one more time, you're welcome, honey. You're welcome. You can always go back on my YouTube channel and you can find it on there. Yeah, I won't take it down. The only drawback on YouTube is that you just have to hear this extra commentary. That's the only thing. You can kind of skip through some of this. Okay. So now I know let me see. Jazeel had a question. So Jazeel, I've got you now. Okay. So let me go ahead and okay. You're welcome, Diana. So on this next problem, Jazeel had a request, and that request was for this next problem. So let me actually do this. Let me tab over. Here we go. I'm going to put another screen up. Okay. So now you've got this is the formula that Jazeel had right here. It was AlI3. So that's aluminum iodide, solid, plus potassium. So it's already balanced for me. Produces 3 Ki plus aluminum solid. Okay. So right here, you've got aluminum iodide plus potassium producing potassium iodide plus aluminum. Okay. The question was, how many moles? Let me write it out. How many moles of aluminum are made if 1.34 moles of aluminum iodide are reacted? I know I write sloppy, y'all. With 3.21 moles of potassium. Okay, that's the question right there. Okay. And I'm going to read it again because I was trying to write fast and look at the screen. How many moles of aluminum? So let's put an X over aluminum. How many moles of aluminum? Okay, we're looking for that. Are made if 1.34 moles, so they're giving you that number, if 1.34 moles are reacted with 3.21 moles of potassium. Okay, so since they gave you two different numbers, you can actually choose whichever number you want to use, okay? Because you're going to still get, the answer overall with that. So I'm going to take the first number right here, the 1.34, okay? Just so you guys can see this. Here's the deal. Because I originally started off with, and let's look at the coefficients so you guys can figure out what I'm talking about. The imaginary number in front of aluminum iodide is 1. The coefficient in front of potassium is 3. The coefficient in front of potassium iodide is 3. And the coefficient in front of aluminum is 1. If my original recipe called for 1, and then it goes up to 1.34, what do you think aluminum is going to go up to if we're using that as our choice? The answer is going to be the same thing. It's going to also be 1.34. Okay. So, but again, because I'm a visual learner, I'm going to write it out so you guys can see that. So I'm going to take that 1.34 moles of aluminum iodine that they gave you. And because I'm trying to get to the moles of aluminum, this box right here that I'm boxing in, that's going to tell me what to put down from using my coefficients. So right here, I'm going to put 1 mole of aluminum on the top. and 1 mole right here for aluminum iodide. And when you cross out your like terms, you'll see that 1.34 times 1 is going to give you 1.34 moles of aluminum. Okay? Now, if you would have used the 3.21 instead, then that answer would be 3.21 moles. Okay? But let me show you so that way you can see it visually. Because your teacher can give you two different numbers. It's whatever number you choose to start with. So in this case, if I go with the 3.21 moles that they gave you in the problem, and that was a potassium, okay, 3.2 moles of potassium, and you're still trying to find the moles of aluminum, the only thing that will change in this problem is what you write here in this box. So I'm still going to write 1 mole of aluminum on the top, okay? But on the bottom, I'm going to use my coefficient for potassium. And right there, there was imaginary, well, there is a 3, not imaginary, there is a 3 right there. So I'm going to put the 3 on the very bottom. And that's moles of K. And of course, you know that your moles of K are going to cancel out. Oh, okay, okay. You're going to say 3.21 times 1 and then divide that by 3, and you get 1.07 as your answer. Now, that is if you used the 3.21. So you said, so the numbers don't have to be used together. No, I think I tried 1.34 and it marked it wrong. Okay. Yeah, so if this is what they give you, how many moles of aluminum are made if 1.34 moles of aluminum iodide are reacted with 3.2 moles of potassium? Yeah, you can, normally when they give a problem like that, it's normally only one number that you would start with. So you don't actually have to use both numbers in the problem. And I would have to see that problem also, because if this is just stoichiometry, yeah, no, you wouldn't be using both numbers. Yeah. Mm-hmm. Yeah, you would have to use both numbers. Okay. Unless you're welcome, you're welcome. The only time you would have to use both numbers in a problem is if you're talking about limiting reactants. Okay. If you're talking about limiting reactants, then that's a different story. But if it's just a problem like this, yeah, you just choose one number and then you just use that accordingly. Yes. So on Monday, I will not be able to go live on Monday because I'll be judging some, it's SciTech week at my college, and I'm going to be judging some science fair, not science fair. There are some research projects that the undergrad students are doing as well as the graduate students, and I'm going to be judging those. So I will not be able to go live Monday during my normal time, but I may go like to do problems like this, but I may go live to show you guys, you know, where I'm at and what I'm doing. So you all kind of be a part of that. Like yesterday, I wasn't able to go live fully because I was out doing science experiments with children because they were out of school for a half day. So I go in and do, you know, experiments. And I believe, yeah, Giselle, I believe you were on with me yesterday, just briefly. I was on there for a little bit. Okay, so Giselle said, oh, tongue-tied, sorry. But even in limiting reagents, I don't think they go together. They are divided separately by their coefficients. Right. You have to treat them differently. Right, they don't go together, but you do treat them differently. So if you were given a problem like this with a limiting reactant, oh, matter of fact, oh, this is a prime example. If you were given a problem like this for a limiting reactant, what you would have to do is figure out which one of these compounds is the limiting reactant. So in this case, let's go back to our balanced equation so you guys can see that. So because these two are together, a limiting reactant is typically dealing with what happens as the product or as a result of the products. So your reactants are on the left side and your products on the right side. So if this was a limiting reactant problem, you would have to determine which one of these formulas here would actually be the limiting problem, meaning the one that's going to yield the smallest result, the smallest result. And if we look at this, we would say that it is potassium because potassium provided the smallest number, the 1.07. So yes, that is the difference there. That is the difference. Thank you, Raven. Raven J. Okay. So, um, if you guys don't have any further questions, what I'm going to do is, again, you all can go on to my YouTube channel, and that is Learn Chemistry with Professor TK the Chemist. Oh, you're welcome, young lady. You're welcome. Okay, you're welcome. And if you have any questions, Raven, don't hesitate to let me know. Okay, don't hesitate to let me know. And you guys can always connect with me by clicking the link in my bio, and it'll take you straight to my website. And you can get like a free 30-minute consultation so we can kind of talk and see what areas or areas that you need further help in. And then we can kind of set up some tutoring sessions as well. So I'm all ears when it comes to tutoring. You know, whatever questions you got, we can go straight through them. Homework questions, we can go straight through them. Okay. So if there aren't any further questions, guys, I'm going to go ahead and get off. Y'all, my day is always jam-packed, but I dedicate my hour to you guys every day, Monday through Thursday, unless I have something else going on, like STEM outreach programs or tutoring, not tutoring, excuse me, STEM outreach programs or anything of that nature. I'm always wanting to make sure that I dedicate this 1 hour, this lunchtime time with you guys. Okay. Take care, Giselle, and you have a great rest of your afternoon. So you all have a wonderful day as well. And I appreciate you guys for hopping on. And if I happen to come on at night or on an odd day, make sure you all put on your notifications so you don't forget to connect with Professor TK the Chemist. Have a good one. Okay, thank you, Diane. I appreciate that.